Did you see that? When the ray of light passes through a rectangular block of this transparent material, it bends as it enters the block. As it leaves, it bends back to its original direction. As you probably know, the bending of ray of light when they travel from one material to another material is called refraction. Why does light change direction when it passes from one material to another? Now, in this laboratory instruction is designed to answer and to understand exactly that phenomenon. It is simple to do at home during this pandemic. This instruction uses a jelly from your kitchen and a red laser pointer. The result is profoundly surprising. The first part of our instruction is preparing the jelly. It must be done by the student before the class. It can be saved in the refrigerator a night before. And one thing that needs to be considered is the thickness of the jelly. In this setup, it is 2 centimeters to get a better result. Second, we need to cut the jelly into 2 different shapes, rectangular shapes and semicircular shape. You can use a protector to help you shape the jelly. Why do we need a jelly? Yes, it replaces a rectangular blocks or a semicircular of glass or perspex that's widely used in the school laboratory. Our last preparation is to provide cardboard with angles. We can use a cardboard with angles which has been covered using a clear masking tape. Why do we need to cover the cardboard with a clear masking tape? The first Snell's law of refraction states that incident ray, the normal, and the refracted ray all in the same plane. Take a note, the normal is an imaginary line perpendicular to surface, while either angles of incidence or angle refraction is always measured from under normal as its zero mark. Now, let's do the demonstration. From this demonstration, you will notice the direction in which the ray bends depends on whether it is entering or leaving the glass. This is the second law of refraction. The ray bends toward the normal when entering the glass, and the ray bends away from normal when leaving the glass. One consequence of this is that when a ray passes through a parallel side of the block of jelly, it returns to its original direction of travel, although it is shifted to one side. It is the same as we look at the world through a window. Can you explain it? Finally, why does light change direction when it passes from one material to another? The answer lies in the way its speed changes. The light travels fastest in a vacuum and almost as fast in air. It travels more slowly in glass, water, and other transparent substances. Does light change its direction when it's entering the jelly along the normal? And does it still undergo a change in speed?